Hello, meet Articosa, the legend of mathematics. Actually, I'm not a legend because legends are from the past. So I'm the new vision, the true face of math. Wow, beloved, how can I become a true face of math? You see me, you see math. That's how I became true face of math. The only love that you get from math is through understanding. So, what can I say to you? Understanding, that's what matters in mathematics.
Before, you thought solving equations like z squared plus 4 is impossible. But it is possible. Since you recall that the square root of a negative in your calculator is undefined. But when it comes to complex numbers, that's not the case. That's a new set of numbers that we're about to discuss. So from this equation, we have z squared equals to negative 4, meaning z is plus or minus the square root of negative 4. But since negative 4 can be written as the product of 4 and negative 1, we'll have our z being given by plus or minus 2 the square root of negative 1. And square root of negative 1 is the imaginary. So we have plus or minus 2i. So z has got two solutions, minus 2i and positive 2i. So meaning z squared plus 4 can be factored into difference of two squares, z minus 2i and z plus 2i. And also we can represent our solution in a complex plane, which consists of the imaginary axis and the real axis. Since from z squared plus 4 we have two solutions, we have complex number z equals to negative 2i. So under the complex plane, it will be defined 2 units downwards, and also have this complex number z defined by 2i, which will be defined 2 units upward. So to have a better picture about this, let's first define what a complex number is. So generally, z is given by x plus yi, which represent a complex number. In this case, your x and y are elements of real numbers, and I is the imaginary, as you know that I is the square root of negative 1, so I squared is negative 1. We also refer x as the real part and y as the imaginary part. So x is defined on the real axis and y on the imaginary. So looking at complex number z equals to negative 2i, our x here is 0 because it's here. You can see x is 0, this part. So we have this, we can write it as 0 minus 2i, and our y is negative 2. And for z equals to 2i, our x is still 0, but our y now is 2. So a complex number can take any value depending on the values of x and y. So either one of them can be 0 or can be negative or can be positive, or both they can be. So it will also depend on which quadrant is our complex number defined. We also define a distance from the origin to where the complex number is defined. So this is known as the modulus of a complex number. We'll denote it by the absolute value of z. It's also known as r. So through Pythagoras, we have shown that the modulus of z will always be given by the square root of x squared plus y squared. As for z equals to negative 2i and z equals to 2i, we have the modulus of z as 2, because if you can check on this one, we're having the square root of 0 squared plus negative 2 squared. We get 2. And also for this one, we have the square root of 0 squared plus 2 squared. We still get 2. Most importantly, we'll define the argument of a complex number as the angle that will be measured from the real axis to where your complex number is defined. We'll denote the argument of a complex number by arg of z, which is theta. Looking at our complex number z equals to 2i, it is defined by an argument which is 90 degrees. Since we prefer rods, we take pi as 180, so which means the argument of z is pi over 2. And depending on this line of the imaginary axis, and as this line of the real axis act as the mirror, so anything above is positive, anything below is negative. So reflecting the angle pi over 2, we have negative pi over 2, which will define our z equals to negative 2i. So for any complex number defined on the imaginary axis, below its argument it will be negative pi over 2, and above its argument will be pi over 2.